Another principle of Pluto Scanner program is a spectrum view with a very large zoom, actually 1 million times zoom. As you know, a lot of different programs can be used to monitor a very wide spectrum, like this nice Maia SDR can see about 60 something plus megahertz of the spectrum. Different versions of HF WebSDRs can view frequencies from 0 to about 30 megahertz, the whole HF band, but let's try to zoom in. We will now see SSB signals, FT8, but this is bandwidth 2.4 kilohertz and we cannot further zoom in. With programs like Spectrum Lab, we can zoom in to a very fine resolution of fractions of a hertz, but we cannot see many kilohertz or megahertz span. Let's see how the Pluto SDR scanner works. The resolution is such that we see a gigahertz of the bandwidth. We are viewing a satellite frequency of the QO-100 satellite from 10.4 to 11.4 gigahertz, and the distance between the two marks are, I believe, 1, 2, 3, 4, 5, 6 100 megahertz. This should be amateur radio transponder of the satellite. Let's zoom in. We are zooming in. The zoom factor is 750. Let's view this part. No, let's view the whole narrowband transponder of the satellite. I have opened the narrowband transponder WebSDR, so we can see and compare low beacon, lower beacon, upper beacon, and this is exactly what we see. Let's try to zoom in to the upper beacon here. Okay, need to move it a little bit. Upper beacon, and I believe that's it. Let's put a cursor here, and this is our 3 kilohertz of the bandwidth, and we cannot zoom in here. We cannot see what's here. Okay, let's zoom in here from 1.7 thousand to 100,000. So you see here's the upper beacon. Let's zoom in to its maximum zoom, 1 million times. We see a carrier, and now a CW signal will start, and at the distance I pushed control and I'm using a ruler tool. The width is about 400 kilohertz. Let's zoom out a little bit. And at some zoom we will be able to actually see and decode the dots and dashes of the CW signal. But you see, when we zoom in, the frequency resolution increases, but the time resolution gets very bad, and we cannot decode anything anymore. Let's look close to the FT8 band. Now I turned on 15-second markers, and this should be FT4, since it's a half of 15 seconds. Let's look at some other parts of the QO-100 narrowband transponder. In the very center there is a PSK beacon. Here is some SSB signal, very nicely looking. And let's zoom out a little bit to show you the wideband transponder. Let's switch the polarization of the LNB. The web spectrum monitor of the wideband transponder is showing the main beacon, and here it is, and there was some other signal which was turned off. Another narrowband signal appeared, and it's also on our screen here. So let's zoom out so you can see the 1.00 zoom and what's on the satellite. There should be a lot of TV channels or internet channels, don't know. And if I change polarization right now, I will switch to another polarization. You see these signals mostly disappeared, but another one appeared back. As for the low signal level, it's not necessarily that this signal comes from the QO-100 satellite. Maybe this one is from some nearby satellite which is close to QO-100, and that's why the signal is leaking into our receiver. Okay, let's press stop and let's try to listen to some other frequencies. Well, now I connected an antenna directly to Pluto SDR, and I'm trying to view the whole radio frequency span from 70 MHz to 6 GHz. I don't see much here, but let's zoom into some of the frequencies. Here is a radio broadcast band, and we can clearly see FM transmitters, a lot of them weak and strong. Let's look at 70 MHz radio emitters band. It looks like nothing interesting here. We don't see any amateur radio stations here. Let's get back to frequencies like 200 MHz. There should be 175 MHz actually. There should be, I'm pressing Ctrl and I'm measuring 1.5 MHz is the bandwidth, so it should be digital audio broadcast plus transmitter on the air. What else? Some other DAB transmitter, and yet another one, a distant one. Let's look at satellite and at cell phone frequencies, about 800 MHz here. as well as 900 and something megahertz as well, and back to full 6 gigahertz band, from 70 megahertz to 6 gigahertz actually.